Morning and good afternoon and welcome back to this week's Schlumberger Academy appointment. So today we are talking about mass spectrometry using in logging while drilling for the hydrogen detection. So the mass spectrometry is unlike a traditional method to use for traditional surface in mud log gas analysis. So the mass spectrometry integrates into bottom hole drilling system and is enabled to relieve the presence of hydrogen for the detection of formation gas and hydrocarbon with high resolution depth. So here we have, from the courtesy of Schlumberger, we have an example of this, and so it's clear that we have this kind of example with relief of mass spectrometry and the presence and detection of hydrocarbon. So what is the mass spectrometry in log wide drilling? So the mass spectrometry, as abbreviated as MS, measures the mass to charge ratio of ionized particle, allowing the detection and quantification of chemical compounds when applied in logging while drilling. It analyzes formation fluid, gas or volatiles released while drilling in situ, provide directed and intermediate formation. So it's really recommended to use mass spectrometry, for example, for analyze the isotopic signature of gas and origin of gas, especially when we are talking about to the hydrogen and other isotopic elements that are present in trace element in advanced setup. So hydrocarbon composition is different to this way, and how it works mass spectrometry in logging while drilling tools. There is essentially two models. The first model is constructed by gas extraction model of downhole. Gases are liberated from rock cutting or pore fluids due to the pressure temperature change of mechanical action, and ionization chamber that the gas is ionized using electron impact or other methods. Mass analyzer, and the mass analyzer is typically use a quadrupole of time of flighting TOF analyzer to separate ion based on their mass to charge ratio. The data transmission is the last part of of mass spectrometry, and they read the K parameters are transmitted to the surface via mud pulse telemetry of EM telemetry. So which is the function of gas spectrometry in logging while drilling technology is to make an assert and confirmation of geochemical and chemical composition of rocks, and make the instant analysis of fluid formation and gas in the well bore. This gas dissolve or mix with drilling mud and are carried out to the surface. Because why we use these technologies? Because the hydrogen is extremely volatile, and so they need much more attention to use to make instant and quantitative analysis of gas in rocks that are evaluated. And the mass spectrometry extracted gas is analyzed using a quadrupole or time of flight mass spectrometry. They provide a rapid analysis in minutes than 1 or 2 seconds, and the gas including are the following. We are analyze the presence of methane, of nitron and hydrocarbons, and hydrogen, and also the CO2. So there is a spectrometer that makes the real change to mass and the ratio, allow identification and quantification. So the detection of hydrogen as gas is just tested in some serpentinized rock, and with good result. We in particular detected the fracture that can move out the hydrogen, identify the hydrothermal alteration zone, trace biogenic or thermogenic gas, evaluate hydrogen storage reservoir, or manually occur when we have this system. So there is an example of the gas spectrometry with different peaks that we can analyze. But generally, the presence of the hydrogen gas is also linked to some minerals like gypsite, anathracite, neton, stuvite, and chlorophyllite or halogen, or some halogen minerals. So there is a variety of rocks that can be contain naturals and white hydrogen, and this is the kind of the projects. So we have several applications starting from the geothermal drilling, because also in geothermal fluids can we have the presence of hydrogen, often indicate hydrothermal activities can correlate with high temperature zone. The natural hydrogen exploration is using this is another application using emerging exploration for natural hydrogen, as we say. And we have also the previous technique, the mud gas logging optimized, compared with the conventional gas chromatography analysis. Mass spectrometry is fast and more precise. So, which is the data input, data output? Real time, integrate with the LVD logs for more correlation. Challenges, surface contamination. So we have some trouble to afford when we are providing this kind of analysis. We can have, for example, the surface contamination by other minerals or other, for example, this problem is frequently happen in geothermal drilling, because we have the fluids that is linked to the geothermal phenomenon. We can have a much more contaminated, and so it's not too easy separate the atmospheric, for example, hydrogen to the subsurface hydrogen. So we have an attention and expertise calibration at drift, and also we have the other challenge is the lag correction due to mud circulation time from bit to surface. An example workflow in drilling formation. We have some application just from the drilling formation, the gas extractor, and this is the most and the principal application of gas hydrogen detection. I want to show you also some coding that can be explained a typical problem of not only of gas chromatography, just we say in the past, but the mass spectrometry in LVD. So this is a typical acquisition of mass spectrometry during logging while drilling for hydrogen detection. This dashboard, this app in Streamline, show you that real-time hydrogen detection use mass spectrometry logging while drilling. We are just explaining the hydrogen in millions per part. We have a high hydrogen zone production that is just linked to fractured rocks, fractured serpentinite rocks and geothermal. So we have a hydrogen detection with DEF. We have, for example, this is a plot of concentration of by millions per part of gas hydrogen, and we have also checked the high concentration with this peak cross, red cross, and this is the show. I show also the table. The best higher concentration is in this part, and so we have this kind of data, and is interesting in evaluation information that that underline there is a high fracturity serpentinized rock in this interval of depth and in this interval of depth. So thanks for attention. We are coming into the next week to another webinar, another course, and I think in the next week we are talking about the resistivity log for gas identification.